Hey everyone. If you're watching this recording, actually, I'm a bit sorry. Probably I fell ill between today and tomorrow. Hi, Wrocław. I'm sorry I couldn't be there physically. COVID sadly finally came for me, but I'll still try to do my best to give you a talk that you're going to enjoy. And hopefully it's going to be interesting for everyone. Yeah, so let's start right with it. The new architecture is here. Like, isn't it great? Like, what should we do now? Like, you see, I've been jokingly, I've been doing talks where I say like, oh yeah, the new architecture is coming next year since literally like January 2019. Then I did a few more times during 2018. I was like, yeah, sure, yeah, it's coming, absolutely. And even in early 2020, I was like, yeah, sure, it's coming, it's coming. But now it's actually here. Could you believe it? So let's try one last time. I'm Lorenzo Sciandra. I'm a senior software engineer at Microsoft, and I'm a React Native core maintainer. I've also been a releaser. This is since 2018, so now the years are starting to rack up. And today I want basically to fulfill two goals, to have two things burnt in your brain. So to really like make sure that you're here with me and you're gonna get that same level of energy of like the passion of like reaching these goals. I literally try my best to find the worst animation possible. So here it is. Like the first goal is to understand the core concepts of the new architecture. And the second one is the awareness of the challenges in moving to this new architecture and what we can do to help plan your migration story. Now, before we do that, of course, let's take a second, a step back. Let's try to go back to see what the old architecture, what is usually called paper, looks like, so that we all have a baseline of common understanding. Now, this graph may sound a bit more complicated than what you're usually used to, but this is pretty much how the old architecture has been working so far. We can easily recognize a few known elements. We see Metro on the side, we see JSC, JavaScript core, as the engine where the JavaScript bundle gets run. We have the mythical bridge, we have JSON going back and forth, and we have Yoga to handle the native UIs. This is pretty much how React Native works when you talk, let's say, of the paper way, the old architecture. And as we are all aware, it has a few limitations, like, for example, the fact that back when we were still using JavaScript core mostly on Android, you literally had to bring it along in your app because JSC was only present by default on iOS. Of course, the bridge, we can talk for hours about its limitation, but basically boils down to the fact that it's one bridge and it's a queue of sync batch messages. So what happens there is that, well, first off, it's easy to reach a bottleneck when you are sending back and forth a lot of messages, but also because of this async nature and this batching system through JSON, we don't have typing, we don't have any real awareness between JavaScript and the native modules and the native side in general. And this is also creating another problem, which is that, for example, because the app doesn't really know when it needs to load certain native modules. So let's say the Bluetooth module, maybe you're only using it like 4 screens deep, but because your app doesn't know, it needs to load it at startup time. So the startup time is slower than it should be. Now, of course, we're not just here complaining. We're not just the first ones to ever discover the limitations. The Meta team actually realized these problems like very early on. So what happened is that they went back in the lab and they tried to come up with something new. And this is what the new architecture is all about. Here I'm using an emoji that is literally like the only emoji that I could think of that is kind of related to the names that you're gonna hear later, but it's not used already by like in some common known ways. So yeah, just bear with it. If you don't like it, just ignore it. It's fine. It's not official. Now, the key change of this new architecture, which kind of goes back to what I was saying earlier, is the JSI, the JavaScript interface. And what this does is really enable through, let's say, interfacing, so awareness between JavaScript and the native side. And because this JSC layer is done in C++, This means that we're not really limited to, let's say, Android and iOS, but literally anything that uses in some form C++, which means basically everything. And this really, as you'll see shortly, really like revolutionizes the way we can interact with native side. For example, for the native modules, all of a sudden, because we have this direct reference, like literally from the code perspective, it means that we can send methods, we can send commands synchronously, so with a higher priority, and also we can also only load a module when we actually need it. So the example I was making earlier about the Bluetooth, all of a sudden, you will only load it, let's say, if you have the Bluetooth on screen 4, when you're on screen 3, and that means like a shorter startup time. Similarly, for the UI side, so what is called Fabric, we are now able to have Yoga and the JavaScript side like have proper communication. We have multiple rendering priorities. This is thanks to React 18 and what is called concurrent mode. And also, like, because of this direct awareness and the multiple rendering priorities, it means that we can literally say to the app, for example, when you're scrolling a huge list, like, hey, this UI update command is a higher priority, so do this first. So this will make an experience feel more flawless, feel more native-like. Now, there's another step, which is kind of like an extra step that will happen towards the end that has changed names so many different times. Currently, I think that the most meaningful name is bridgeless, and simple as the name implies is boom, basically make the bridge disappear. Why is this a separate step? Basically, to ensure a smooth transitions to the new architecture, the meta team wants to keep the bridge around so that basically the old world and the new world can kind of coexist for a bit. And so it will only happen in the future that the bridge will disappear once and for all, and we will only be in this new native way, new architecture way. Now, not only that, now we've like shaped the new architecture, but there's one extra step that we can take, which is potentially optional, but it's highly recommended, which is the use of the Codegen. What the Codegen does is enable you to use your JavaScript code to define the interfaces of all your, let's say, native code facing code. And by doing that, it will take your JavaScript, your TypeScript or Flow types, and will generate the equivalent native side interfaces, which basically is a long way of saying, like, it's not likely that you will need to learn C++. You don't need to learn necessarily any native code language. Like, there's a level of tooling that has been introduced to help, remove that step. And also, like, in a backward way, if you want, because C++ is strongly typed, this implies that your code will need to be very, very tightly typed too. And, good typing in your code is equivalent to, better code at the end of the day. Now, this Codegen, as I was mentioning earlier, basically allows for not only Flow, but also TypeScript. And this is because basically it's kind of like these 4 modular blocks that the code goes through to generate the interfaces, and we can easily swap the parser. Basically, Codegen will be able to support both systems kind of quote-unquote easily because of this ability of just like replace one module with the other one and then generate the types from your TypeScript or Flow code bases. Now, all of this said, this is what the new architecture looks like. It can be, a bit overwhelming. It can be a bit of a lot. So let's try to take a step back and more like just do a comparison. So on the top there, we have the paper architecture. On the bottom, the new architecture. What are the main advantages? So we have JSON to communicate, no more, which is great because it means that finally we don't have a single bottleneck. We have faster interaction. We have a faster startup because, again, the native modules now, there's true awareness of when they need to be loaded on. So they're what is called like lazily initialized. We have better memory management because all of a sudden, the OS in which the app runs understands better what's going on within your app. Like if before it was kind of like, let's say, potentially like kind of a black box of JavaScript, and the app was kind of like, well, yeah, that's running. I have no idea what it's doing. Now with more like native interoperability, it will say, oh yeah, this is a screen. Oh, it's showing 4 screens. Maybe I can optimize through them, put them in low RAM mode or something like that. And basically all of this should also lead to less crashes, type safety, and also like we should get to a new and improved developer experience thanks to the new tooling. Now, so far, everything sounded maybe a bit too good to be true. Okay, so on paper, everything of the new architecture works really, really well. But is it really that simple? What's going on here? Like, how do we actually start using the new architecture? Where's the catch? Now, for the sake of this presentation, I want to point you to what we have already on the website. In particular, if you go on the guides, there's this section called the new architecture that kind of like goes in deep of what I'll just be talking about. But basically, if something doesn't sound right or it sounds a bit too magical, please refer to this side of the documentation. And also, while we're here, I kind of want to give like a round of applause to Ricardo, Nicole, and the rest of the team at Meta for like really trying to step up their game when it comes to creating documentation to enable and make it easier for people to get to the new architecture. And not only that, they also like saw my slides in advance. So like everything I'll be mentioning later, they're kind of already aware, let's say. And not just that, one more premise, let's say. Let's assume that your code base, for the sake of what I'll be talking later, is predates 68. So you built your app, your library before React Native 68, simply because from 68 onward is when some, let's say, base code is already in place for the new architecture. But for the sake of our conversation, it doesn't really affect too much. I just wanted to make this premise anyway. Now, for libraries, what does it take to get your library from, let's say, paper style library to a new architecture style? Basically, as you can see here, it seems kind of like just a few steps. We have a refactoring step, then you need to basically do an extra step of Codegen, let's say declarations, and then you basically extend the native interfaces that are generated through Codegen. For apps instead, things start to get a bit more complicated, but not necessarily complicated, but there's more work to do. Luckily, there's also this good practice of the fact that you can do Turbo modules and Fabric at separate times. You can do steps per each of the platforms, kind of like separated from each other. The idea here is that for Turbo modules, you kind of want to reach that ability to switch on the flag. For Fabric, similarly, you need to switch on a flag. And as you can see, there are a few things here and there that you have to do. Now, what could go wrong, right? This graph seems, understandable enough. The steps, we have them on the guides. So, what could go wrong? Actually, quite a few things, sadly. Now, to not make this talk too pessimistic, too negative, I try to put a spin on it. So let's call these problems challengers. Like, let's start with the first one. Let's start with typing. So as I was mentioning earlier, Turbo modules, Codegen, basically you need to have TypeScript or Flow in basically all of your code. Like you should have that there anyway, but now it's kind of like more mandatory. So the good thing about the Codegen is that it already supports primitive function, object, and array types, which is great, right? Then you start looking a bit closer to it, and you realize that union types, custom types are not there. All the types can be read-only about the types that you use to interact with native interfaces, and you need to have the exact same signature across Apple and Google's systems, so iOS and Android. And this may create some problems, like if before you had like different ways of connecting to your native module on iOS and Android, now you will have to do some refactoring. And not just that, but yay, TypeScript support is still in beta. Like the Meta team had to go out of their way to introduce TypeScript support in Codegen, but because they don't use it themselves, like it's a bit harder to get Codegen to be fully comprehensive. So basically typing is a first challenger because of these limitations, and hopefully we can get rid of them as time goes on. The second challenger, I just called it the new arc configuration, and this kind of goes back to the two graphs I was showing you earlier. In particular, there was always like that first step of like refactoring, kind of like hand waved a bit on it. But really, when you start looking closer into it, so let's say here we're again in documentation, let's see what it takes for a library to be Fabric compliant. As you can see there, the sub menu of the page is kind of long, and in particular, like all these modules that you see here, like find node handle, UI manager, set native props, and dispatch view manager command, like all of these methods need to literally disappear from your code. Like you need to refactor heavily your code if it was using any of those things. And even for require native component, luckily you don't need to refactor it completely, but it needs to be moved to a separate file. So even if you never used any of these other methods, like you will still have to do some refactoring because of require native component. So you see, like getting to the new architecture, the refactoring magic step is kind of like complicated and hides a lot of complexities. And not just that, like when you start looking through this documentation and start looking at the steps, and maybe you even noticed in my graph, I didn't point it out because I wanted to have the kicker here, but basically, if you look at the way you need to define the Codegen configuration for your libraries, for some reason in iOS and Android, you need to do it into separate places. Like for iOS, you do it in the package.json. In Android, you need to do it in the build.gradle. And like even why? And luckily, this has been addressed. It's fixed in 0.70. So why I wanted to mention this if it's already fixed? Well, to introduce a concept, the concept of feedback loop. The reason why this got fixed is because basically maintainers, developers kind of like went back to Facebook and told, hey, we know that this is step you need to do. We think this is not the way it should be happening. Can you please fix it? And they were reactive in addressing it. Now, the third challenger is probably the one you know the most, or it's most likely that you're already aware of it, and it's around third-party libraries. So let's take, for example, the React Native directory. Like this website hosts almost 1,100 libraries. And again, as we mentioned, like a library needs to move to the new architecture to be fully compliant. And how can we know which ones are on the new architecture? So there is this thing called the React Working Group, which is a working group that the meta team has set up for the new architecture, in which there is a discussion section of this repo that is used for communication and interaction. And in particular, there's a section there, the libraries one, where maintainers are invited to give a status update on like the migration status. So maybe you want to try to take a guess out of those 1,100 libraries, how many have already migrated. But I can tell you that currently it's 4 + 1. And the +1 is only because this person just like hard forked a library and made a new version that it's new architecture only. So as you can see, there's a lot of work there that needs to be done. Now, oh, what's happening here? What's going on? Oh, no. Oh, not another challenger. Okay, so let's actually take one more minute to talk about React 18, because as I was mentioning earlier, with Fabric, we have this new powerful concurrent React mode, but that means React 18. And what does React 18 brings along? So in a way, we've always been used to this kind of like linear flow, very understandable of like, you trigger a change and then the trees, entire component tree kind of like updates accordingly. And it's very like, the flow is very simple. It's linear, it's one directional. Now with React 18, because of all these new improvements and optimizations, this more or less the situation. Like we don't have and it's not as easy to understand or to follow along, like in particular things like automatic batching that takes separate a set of status updates and like kind of like batch them together. Like there's a risk of inconsistencies across your app. And in particular, this is very evident in a state management library. So you want to make sure that when you move to Fabric, when you move to React 18, your state management library is React 18 compliant. Like, I'm not even joking. You really need to go and check if your state management says explicitly, yeah, I support React 18. For example, since mid-April, React Redux supports it. Other libraries I've heard that supports it well are listed here. And by the way, the same thing is for GraphQL clients. Like, really, like, basically, you need to assume that whenever you're going to move to React 18, you will have to update your state management to the latest version. To aid you with like keeping an eye on things and making sure you have a full understanding, I actually found this very like insightful and in-depth blog post about the new wave of state management libraries for React. And it's very good. And he also touches better on what I was just talking about of how state management in React 18 may have some friction. Now, as I was saying, like so far, I've been trying to, put it a bit on a joke. I tried to put it a bit lightly, but honestly, like there's so much more that I didn't want to really touch on, but there are more problems. Like the new architecture, yeah, it's great, absolutely. But when you go and try to do it right now, it's still kind of hard. So also, I want to acknowledge that I didn't show you any benchmarks. I didn't like say, oh yeah, the new architecture is X times faster. And this boils down to the fact that there isn't really any good report on benchmarks or benchmarks like showing the improvements of the new architecture. And this is because basically Meta hasn't put out any of these. And the few ones that I found, I didn't feel confident sharing because I feel they were like done by single developers that they didn't really have a relationship with. And I don't feel they were like as official as I would like to have them for this type of presentation. So for now, basically, I'll just boil it down to there are no benchmarks, yay. But you need to trust the fact that it's a good migration. It's a really good new architecture. Now, based on the fact that, let's say we agree that the new architecture is great, we know that there are challenges, how do we plan for this? How do we make sure that we can get there without creating too much pain or troubles for anyone? So I spent a bit of time trying to come up with a plan, and I hope this is going to be at least useful to have a conversation within your companies. I'm using this internally at Microsoft, and basically, this is it. As you can see, it's a bit small, it's a bit complicated. Don't worry, let's try to just like walk through it a bit. And worst case, I've put the slides out as soon as I'm done with the talk today. Well, when you are going to listen to it, so on Thursday evening for me, I'll put it out so that you can watch it and discuss it more clearly. But basically, the idea here is that I'm starting from the perspective of, do you have a library? Do you have a library? If you have it, migrate it now. Like the easiest way to get to the new architecture is when libraries have new architecture support. So that should be the priority. Like if you have any library, you should migrate it right away. Like that should be your first focus. Also, you don't even need to necessarily have a new example app that works with the new architecture. There are solutions out there like the React Native Test App that is an open source project that we have from Microsoft. You can go on GitHub and find it. And basically, it's kind of like a fully fledged app where you can just switch some flags and enable the new architecture in. So you can replace your example app with React Native Test App, and you can switch on the new architecture there. And you have in an isolated system your library working in the new architecture. And I swear this is probably like the easiest way for a library to move to the new architecture. Now, let's say you don't have a library or you've migrated your library, good for you. Like if you have an app, like if it has custom code that is like native module wise, so let's say you created your own native module within your app to better control Bluetooth, extract that into a library and follow what I was saying earlier. like migrate the libraries separately. If your custom code is around new view managers, you can start migrating it right away, because Fabric allows for like different routes to switch on to Fabric at different times. But I would say probably in most scenarios, you're going to have only one React route. So as you're going to see in a bit, Fabric, I've left it at the end because it's a switch on only situation with no backward compatibility. Now, let's say you don't have any custom code, you don't have any libraries in your app. The first thing you should do is modify your code to support turbo modules. Why is that? Because when you turn on turbo modules, they actually have backward compatibility. So even if you're in turbo modules mode, you are able to still rely on libraries that use paper architecture style. So that allows for an easier transition to turbo modules. Now, at that point, basically you have turbo modules on, you have your libraries, you're migrating. Basically what you want is to get to the point where all your libraries or your call libraries have all new architecture support. And why is that? Because after you switched all your native module code to be the turbo modules way, because yes, it's not an automatic step, you can then start wondering about Fabric and introducing Fabric. And at that point, that's when I think you should start thinking about Fabric and you should turn it on. Now, of course, there are a few more things that I kind of want to mention here. I feel we're going a bit over time right now, so I'll try to keep it short. But basically, I'm leaving Fabric at the end because, again, it doesn't have a backward compatibility. So the moment you turn it on, if a library or something that you use doesn't have a Fabric support yet, it will just show up as a red square on your screen saying this module is not supported by Fabric. And also, turning on Fabric means React 18 and the problems I was mentioning earlier, so also migrating the state management. So to recap, migrate your libraries, move on to turbo modules, then make sure that all your libraries support in your architecture, then move on to Fabric. Now, why start now? Like I just told you earlier, that some libraries don't have, new architecture support. Why can't you just wait for everyone else to do the job for you and then you just last minute hop in? Well, one key thing, and I kind of already mentioned it once, is the feedback loop. So there's this new architecture working group, which is built by Meta, where you can apply to be a participant on, but basically is the best place for you to share your experience migrating to the new architecture and let the Meta engineers know your problems so they can help fix them and address them. And I think we should not, undervalue the fact that this is very, very key. The Meta engineers are very smart and they're doing a lot of work already, but they cannot possibly hit every problem and find every single scenario in which React Native is used. So they really need our help to see problems that they haven't seen but just by themselves, like the one I was showing earlier about the Codegen, so that they can address it. And it's incredible. Not many places have this type of feedback loop, so we should really leverage it. So concluding, well, the new architecture is pretty awesome. I hope that the first part of the talk where we're showing you the approach and the technical details of it kind of sold you on the fact that these are very revolutionary in terms of having a cross-platform solution, being able to provide native experiences. Second, migrating to the new architecture will take a number of months for most projects. I think that if there's a takeaway that I want you to take back to your manager, to your colleagues, is hey, we need to start thinking the new architecture now because it's going to take a number of months. And third, supporting those as libraries that you use is key to reaching and enabling the new architecture in your project. So basically, if I had to summarize all of this in one phrase, it would be try fast, fail fast, tell everyone, and help each other. This is literally the one cookie cutter phrase to use for this presentation. Yeah, I hope that this kind of help you understand a bit more. I'm sorry I couldn't be there in person. I hope that this recording did justice to what you were expecting out of it. And yeah, take care, everyone. It's been nice. Bye.